Hi guys, we are from KMTT Automation Engineer student. Today we're gonna show the solution of response system. First, I am Triti.
I'm Rona.
I'm Fasai.
Let's get started.
First, we gonna solve differential equation from KVL. First, we start from minus Vt plus V across 1 Henry equals L di by dt plus V across 2 ohm equals I multiplied by R equal to 0. We rewrite this equation into Vt equals L di by dt plus I multiplied by R.
Let's go to the second problem. We derive this equation from the first problem, and then we simplify the equation to be Vt to become xt, di by dt to become dy by dt. And because of this, we need to change from ODE to be the normal algebra equation. We need to use Laplace transform. So as L and R is the constant value, we have to put it out, and then we take Laplace inside the bracelet. So we got the equation as here. After that, we move the side of the term. So we go to this line, which is ys equal to 1 over s plus r over l. But we need to change this term into yt. And then we need to use the inverse Laplace transform, which is this line. Yt equal to a multiplied by e power r over l and multiplied by ut. But when the time is 0, yt is equal to 1, which makes the e power 0 become 1, and u0 is the unit step, which means if it is the time is 0, it will become 1 this term. So that means a equal to 1. We substitute a back to this equation, and then we get this equation as our answer, which means that if this graph is our input, the output is this equation.
And for the last question, it's asked about step response function. And the first step, we got this equation from the differential equation. And we realize the Vt equal to xt and it equal to yt because we are familiar with xt and yt. And then we got this y particular equal to constancy from the xt functions, and we substitute xt equal to 1 and y particular equal to c in the function, so we got this function, and we solve this equation to got this c equal to 1 over r. And next, from the theorem, y total will be equal to y homogeneous plus y particular. Y homogeneous we got from this equation from the impulse response equation, and yp or y particular from this equations. And when time is equal to 0, we substitute all t equal to 0 in this function, so we will get this line, and when I equal to 0, it will be equal to 2 from the equations, and got this equation, and we summarize this equation to be this, and we substitute a equal to 3 over 2 to this function. We will get the last answer as we see this. Thank you.